us see some applications of this mesomeric effect. Reactivity order of halogen compounds towards a nucleophilic substitution reaction, or can be said substitution with nucleophilic. Basically, it is a SN1 reaction we are discussing, but commonly you can say SN reaction. In this reaction, what happens if I take alkyl halide either with the a nucleophile or with the OH? In a hydrolysis reaction means water with basic medium. This OH is going to hydrolyze the alcohol is formed in the reaction. So, this OH, how best it substitutes is the order now. Instead of OH, some common nucleophile like cyanide minus NH2 minus also can be chosen, but this must be stronger than the X, then only the reaction proceeds. Toward this reaction, you can say that benzyl halides are more reactive. Benzene with CH2Cl or the common chlorine, let us take. The benzyl chloride is more reactive than the allyl chloride. Or let us take only chlorines without having much complication. Then you can have an example like an ethyl chloride we take. Then we will take a vinyl chloride. Then we will take one aromatic case, we will take chlorobenzene. This generalized as a benzyl type. You can generalize as a allyl type. This is example is ethyl, but common is you can say alkyl type. This is vinyl type. This is aromatic, or you can say aryl type. The name is chlorobenzene, phenyl chloride you can say. What exactly the vinyl means? A double bonded carbon has directly the Cl attachment is called vinyl. Double bond next carbon, if Cl is there, we call allyl. Benzene directly attached is called aryl. Benzene next carbon is called the benzyl type. This alkyl or RCl is taken as a standard example in between. If you take with reference to this alkyl, these two are undergoing faster reaction. The reason is explained that this reaction, if SN1 reaction mechanism is proposed, the alkyl halide becomes into R carbocation will be the intermediate. Through the carbocation R plus, the reaction is believed to be proceed. So, in this case also, what carbocation comes in the case of benzyl? Carbocation is a CH2 plus. Now, the group which is attached to the carbocation is said to be a plus M group. So, whenever plus M group is attached to the intermediate, this is the intermediate, not starting material. We have a general principle like let us say this is the starting material, this is the intermediate, this is the product, right? A starting material gives intermediate, gives the product. If the starting material is stable, reaction will not take place, because that itself is a stable one, isn't it? This is the stability, this is the reaction. The reaction will the yes, no means no. If the starting material is stable, reaction will not take place. If this is stable, the reaction will take place. Intermediate, if it is stabilized, reaction takes place. If the product is stable, then also reaction takes place. Quite a number of times, if a 1-butene, 2-butene, 2-butene is formed, which is having a more stability through the hyperconjugation. So, therefore, 2-butene is quickly formed. So, with reference to the product, we will discuss the reaction, yes, takes place, more stable, more takes place. Intermediate stable, yes, takes place. If the starting material stable, reaction will not take place. but here what is that stabilizing? Intermediate. So, therefore, reaction takes place. What is the reason for that? You can say benzene shows resonance, therefore, it is stable in that way also. That is what I said, resonance application, mesomeric effect application several times will be the common. So, in this case the benzyl carbocation is stable because of the benzene shows resonance simply, or the benzene is said to be a plus M group. So, the carbocation is deficiency, through the plus M effect the carbocation is stabilized, that is fine, that is also. Similar the way the allyl also gives a carbocation which is an intermediate, for this one is allyl carbocation. The allyl carbocation is also, the double bond comes here and the positive charge shifted to the last carbon. So, this group is also said to be a plus M group. The vinyl group attached to the carbocation shows plus M effect, or resonance it shows. So, consequently the intermediate is stabilized. So, when allyl alcohol quickly gives allyl carbocation, then gives the reaction. When compared to the alkyl, actually to give the alkyl to the corresponding alcohol, we need a aqueous sodium hydroxide and then boil it. Boil for some time, the reaction takes place. But whereas in the allyl chloride, just a boiling water is enough. Boiling water only, no sodium hydroxide. In this case, just warm water is enough. In the first case, the reagent required is only just warm water is enough. Not even the boiling, just around 60 to 70 degrees. Before boiling itself, benzyl chloride becomes into benzyl alcohol. See, the warm water makes, boiling water makes, here water will not work. You need a base and then boiling. Vinyl chloride, you have to take a concentrated NaOH and then boil it. Boil for some time, then you will get it. In the aryl case, in the case of chlorobenzene, it is much more tough. These two are making tougher reaction when compared with the alkyl. The other one, you see, you need a concentrated base like NaOH or KOH. The second one, high temperature you need, and also high pressure also you need. Especially the pressure around 150 atmospheric pressure we must use. That means it is a highly normal pressure is 1 atmospheric pressure. Only industrially it is possible. In the lab, a glass flask if you take and put that pressure, it blasts out in fact. Temperature is can be manageable around 350 degrees, means that can be easily handled. But the pressure is too much, high pressure, the temperature, elevated temperature, concentration is high. All these three conditions only work out. In fact, reality is, it will be in between this and this. Three can be either this side, that side can be manipulated. The reaction is a patent reaction. It is called Dow processes. Dow processes. It's a plural actually, processes actually. The actual reaction will be, pressure can be decreased as if you increase the temperature, like that. So, all the three conditions need not to be specifically like that. One can go beyond, the other one can be decreased. So, ultimately what I would like to say is, when this is taken as a standard, the other two are having less reactivity. These two are more reactive. The reason already we have found out. These intermediates are stabilized. Then what about why these two are lagging or suffering from the product formation? Why they are not, means see examine the vinyl chloride. In the vinyl chloride, there is a lone pair and the chlorine. So, it makes a resonance like this. The vinyl chloride shows a resonance and the double bond is shifted to the corner. So, this CH2 will become a minus charge, and that side the Cl becomes a double bond. Only two lone pairs, one lone pair is missing, therefore a positive charge is formed. So, there are three separate reasons we are quoting. One is the original molecule gets resonance stabilized. As I said, the starting material stabilizes, reaction ceases out. That means there is no reaction. So, the compound has a stability. Here also we have resonance. For whom? For the intermediate resonance, not the original compound, intermediate is stabilized, so the product gives fastly. If the intermediate stabilizes, product forms. In this case, it is not the intermediate. Before intermediate formation, the original compound has a resonance stability, therefore the reaction will be subsided. Second reason is, in the resonance structure you see the carbon chlorine acquires a double bond. In this single bond, in this double bond, what is net means 1.5 bond you can claim, or it has a partial double bond. That means some extent it is double bond character is there. Here double bond, single bond. So it has some percentage of double bond character. As it becomes double bond character, the strength of the C and the halogen becomes strong. So one way we want to remove it and put a new group, and the other side we are making double bond. So the removal of that halogen or getting replacement will become tough. The other way also you can discuss. In this case, the halogens are attached to the saturated carbon. See, this is saturated, this is saturated, this is saturated. Whereas here the halogen is attached to a unsaturated carbon. On the unsaturated, this is also unsaturated carbon. On the unsaturated carbon, the electron density will be more. The nucleophile attacking is difficult. It is electrophilic prone, that is generally alkenes undergo electrophilic addition. So attacking species, if it is electrophile, electron rich, happily it will attack. So contradictorily, what you are doing is nucleophile, you are trying to attack on this carbon, which is against the concept. Therefore, the nucleophile cannot make any attack on this carbon, and consequently substitution will become a tough job. So vinyl as well as aryl, same reasons, both will have same reasons. Original compound has a resonance stability, and the halogen and the carbon acquires a double bond character, and the nucleophile attacking on this unsaturated carbon, alkene carbon or aromatic carbon, it is tough. Therefore reaction is not taking place. Ultimately what we are quoting is this vinyl group and the halogen, when they are attached, the halogen is a plus M group. Whenever the halogen is attached to the alkene, the chlorine shows a plus M effect and the vinyl shows a minus M effect, and there comes some double bond between this one. This is all reason to not to get replacement. So finally what we say is these two are more reactive, that two are less reactive. Within them also, why the benzyl is more reactive than allyl? Here the intermediate is stabilized by the 1+3 resonance structure. This is stabilized by 1+1 resonance structure. More the resonance structure, more stabilized. More the stabilization, intermediate, more fast will be there. Even within these two, if vinyl and only aryl is given, why aryl is much more less, or why better vinyl is, means vinyl stabilizes 1+1 structure, aryl stabilizes 1+3 structure. More the stabilization of the starting material, more will be the less reactivity. So therefore finally you can say aryl halides are tough to substitute. You can also see the reagent and feel it. Warm water, boiling water, that is aqueous base and boiling, concentrated base and boiling, concentrated in addition to this two, high temperature, pressure. So as you are moving from the left to the right, the tenacity or the concentration of the reagent is going on increasing, then only you are getting the reaction. Means the different halogen compounds are behaving in a different way. Basically we are using this mesomeric concept or the resonance concept and justifying this particular answer. Even within the halogens also we can have this type of the discrimination. All are halogen attached to the benzene, but in the benzene you can have some groups which sometimes make the better reaction also. That example also you can take. So within the aromatic also you have a reactivity like this. A benzene having a chlorine with 3 nitro groups at specifically the position, that is that ortho, para, ortho. This compound undergoes very faster hydrolysis towards this nucleophilic substitution when compared with the 2 nitro compounds, 2,4-dinitrobenzene. Naturally 3 nitrogens and 2 nitrogens you can we will see how the nitro group is helpful. Okay, how the nitro group is helpful for the reaction. A one nitro compound is a better one than even one nitro at ortho, than ordinary chlorobenzene, than a OCH3 or some donating group if I put it at the end, then this order is justified. Why these three nitro groups makes this compound faster means if you internal structure of that nitro group, if you see, the nitro will have a double bond and a single bond like this. If you write the resonance structure of this nitro, the nitro will show like this and the double bond will be withdrawn. So the chlorine attached carbon will get a delta positive nature, right? So full positive will come, but overall we will say that is a positive charge. So if this shift, this will become minus and you will get a plus, consequently this opens. So and the carbon where the chlorine is attached will become a positively charged, right? If nitro is here, this also will do the same thing. If this is withdrawn, you will get a positive here. Consequently, this is shifted, you will get here. That means a nitro on the ortho can make positive here and here and here. A nitro at ortho also will make the positive here and here and here. So only at certain positions the positive charge it is increased. So this each nitro group is able to make positive here and here and here only. This is making here and here and here. So all these three nitro groups at a time, if they influence this effect, this carbon will become thrice positive charge in fact, isn't it? Not at a time, may not be, but at a, if not this one, this like that, if you explain, all the time this carbon will have a positively charged. In such a case, we said a nucleophile attacking on the aromatic carbon is not fair because the ring is rich, but these nitro groups are able to withdraw. So therefore this is somehow it will attack because it is carbon is positively charged, it will attack, and though it is aromatic, this trinitrochlorobenzene undergoes a faster hydrolysis. Just boil with water, I hope you will get a hydroxy compound with three nitro groups. The nitro groups are very strong, minus I as well as minus M. In addition to this two, the nitro should be at only at a particular position, just like inductive effect, the group as it moves from the away and away, the effect will be decreases. That we said it is a distance factor. As the inductive effect showing group, it moves away and away from the site, its influence will be decreased. Here the mesomeric effect will not have any distance factor, but specifically in the rings, the nitro can show the mesomeric effect on this carbon. This nitro can show here and here. This nitro can also show on this carbon. But a nitro here, particularly at meta position, 3 are there so strongly, 2 are there next coming, 1 then next coming. But among these two, if you see, through inductive effect, actually this is closer, this is far away. But the far away is coming first because the nitro can show the positive here and here and here. That means the carbon on which chlorine is there is influenced by this nitro. Whereas this nitro shows positive charge. If you write the resonance charge, ortho to nitro, para to nitro is becoming a positive charge in the resonance structures. The carbon where chlorine is attached is not influenced by the mesomeric effect. However, through the inductive effect will be there. Inductive effect through sigma bond. So inductive effect which makes strong means this only makes. But mesomeric effect, this nitro influences this carbon, this nitro cannot influence. So therefore, this though it is closer, the paranitro is a faster hydrolysis showing than the metanitro. However, the next one there is no nitro, therefore this is normal one. If there is any donating group like methyl or a OCH3, that is plus M group, These are all minus M groups. A plus M groups will have a much more decreased. All minus M groups increases the reactivity, but whereas plus M groups OCH3 shows a donation. Through bond it withdraw, minus I effect is negligible. So plus M effect will be very strong. So this makes a negative and negative and negative. So already it is a rich carbon and it is becoming a negative, means the reaction will become much more tough. So therefore we can say ordinary benzene, when you compare, minus I M groups or minus I groups also help, but minus M groups, especially at ortho and para said positions, will be much influencing rather than in non-advisable position, that is in the meta. If the groups are there, only inductive effect help, but not mesomeric effect. So mesomeric effect has a position factor. So the group should be there, and that too at a specific position. The group should be at ortho and para. Then only the influence will be there on this carbon. As we see, its resonance structures will be showing at this carbon, this carbon, this carbon, this group can influence. But in between carbons are not influenced. Inductive effect will be there, but the mesomeric effect will not be. So therefore, the meta nitro and the para nitro, if you say, the para nitro is a better one than the meta nitro. So the specifically in this case, the mesomeric effect has a positional factor, just like inductive effect has a distance factor. The mesomeric effect has a position factor. So though it is far away, it is suitable to influence the mesomeric effect. It is closer, but it is not suitable. So the meta position is not much useful at all. So therefore, this specific example will give this explanation.